All right. Good morning. Today is lesson 155, which is covering latitude on pages 279 and 280. We're just going to do a quick warm-up today with some mental math problems, and then we're going to jump right into the lesson. So here we go. We're going to have 6 different problems this morning, or this afternoon, depending on when you woke up. But for me, it's morning. Here we go. The first one, 6 times 9 plus 6 divided by 6 minus 5 times 9 plus 15 equals. You should have 60 if you were following along there. 60 is the answer. All right, the next one, 54 divided by 9 times 5 plus 6 divided by 6 plus 5 times 9 minus 15 equals 84. I gave you an extra second there to do the subtraction of 15, but you should have 84, 99 minus 15. All right, here we go. This one's a longer one, so follow along. 8 minus 5 times 9 plus 3 divided by 10 times 5 plus 6 divided by 7 times 8 divided by 4 times 7 plus 3 divided by 5 equals. You should have 9 if you were following along carefully and able to keep up. Hopefully you were close or got exactly 9. Good job if you did. Here's the fourth one. This one's also a little long. 25 plus 4 plus 1 divided by 2 divided by 5 times 8 plus 3 divided by 3 plus 3 divided by 3 times 7 plus 5 equals. Should have gotten 33 here. 33 was the answer. All right, 2 more. They're not as long. 74 minus 14 divided by 6 times 12 plus 16 divided by 4 equals. Can you do that in your head? You should have gotten 34. 34 is the correct answer. That was a longer division one. See if you could do that in your mind. All right, last one. 7 times 7 divided by 1 minus 10 plus 1 divided by 8 plus 5 equals. Should have gotten 10. That one wasn't too challenging for our last one. 10 was the answer for that review. All right, so let's jump into our workbook pages on latitude. We're going to do a real quick review of the time. So go ahead and figure out what your answers are for the different time zones based on what I've given you. And then unpause it when you're done, because I'm going to go over the answers. All right, so you should have been able to figure out, this is not PM, so it's not noon. This was talking about midnight. So Alaska time would be 11 p.m., so it's not even midnight. It's actually a separate day. So let's say this is 12 a.m. on the 27th. This would actually be 11 p.m. on the 26th, still here. And then this would be 10 p.m. there. Okay, that would make this 1 a.m., 2 a.m., 3 a.m. Okay, so remember, the further east we go, the further an hour ahead we are. All right, today's lesson, though, is on latitude, which we've covered a little bit in our history and geography sections. So let's go over these facts. Excuse me. All right, number 1, latitude is the distance in degrees north or south of the equator. Okay, so when we're talking about the equator being that line that goes around the globe, which I have over here, okay? So your latitude lines are going to also run parallel to the equator, and it's how far north they go or how far south, kind of like rungs of a ladder. Okay, so that's latitude. And number 2, the equator has been designated as 0 degrees latitude because the sun, moon, and planets almost pass it directly overhead. All right, so that's basically the starting point, the 0 degrees. So number 3, when you're reading or writing degrees of latitude, north or south has to be used to show the direction from the equator. North of the equator is in the northern hemisphere, so south of the equator would be in the southern hemisphere. Okay, we've talked about hemispheres before. If you were to divide the earth in 2 halves, Okay, north and south. We're not talking about east or west right now. We're just dealing with latitude. So you can't just say 25 degrees. 25 degrees what? Is it going to be north or is it going to be south? You're going to have to indicate it. Okay, just like these two are over here. I've got 17 degrees north and 54 degrees south, and we're going to use them in just a moment. So it has to be indicated. Is it in the northern hemisphere or the southern hemisphere? Okay, number 4. Parallels of latitude run west to east, but it measures the distance north to south. Okay, again, like ladder rungs. How far north or south of the equator are they? The length of the parallels vary, right? Because the length of this line, obviously, going all the way around, is not going to be near as long as something closer to the equator around the bigger center of the globe. So the length is going to vary. However, the distance between each degree of latitude is fairly constant. All right, so it's not like these two are real close and these ones are real far apart. The degrees are still going to be pretty constant. The distance between each degree latitude is approximately 68.7 miles near the equator and 69.4 miles near the poles. So it's pretty consistent as far as distancing and spacing in between each degree. So we can calculate it by using what is rounded to 69 miles. It's an approximate distance between each degree of latitude. Okay, so you can find a latitude's distance from the equator by multiplying its degrees by 69. All right, so if we're at 17 degrees north and we want to figure out how far is that from the equator, we're simply going to multiply 7 times 9, 7 times 6 plus 6. 6. All right, so this 17 degrees north is approximately 1,173 miles north of the equator. Okay. We could do the same thing here. Go ahead and calculate it right there at your seat, and then come back and check to see if you did it correct. Okay. So when we multiply, it's always going to be by 69 because that's the estimated or approximate distance in between this latitude at a constant rate. 9 times 4, 9 times 5 plus 3, 6 times 4, 6 times 5 plus 2. Now the higher the degree is, the farther it is going to be from the equator. So this one, you should have gotten 3,726 miles is its distance, okay? All right, so if you're looking at the class practice section, let's go over the fill in the blanks briefly. A, what is the distance east or west measured from the prime meridian? We've gone over this before. Don't put latitude. Latitude is in relation to the equator. Hopefully you remember it's longitude. You can remember because those lines are going the long way. So when we're talking about east or west of the prime meridian, these are the lines of longitude. Can you see? They're measured going this way, okay? So it's going back to what we had talked about previously. All right, B, the prime meridian passes through which place in England? Remember, it's not pronounced the way it looks. It looks like it's Greenwich, but it's Greenwich. All right, C, the distance north or south measured from the equator, that's where latitude goes, okay? All right, latitude degrees are about how many miles apart? 69, right? That's what we multiplied by because it could be 68.7, it could be 69.4, so they use the approximate distance of 69. All right, the equator is what degrees latitude? 0 degrees. All right, the international date line is at what degrees longitude? You might want to turn back to where we were talking about time around the Earth and the international date line. Did you find it? It's 180 degrees. Okay, 0 degrees is the prime meridian when you've gone halfway around the globe, you are at 180 degrees, because 360 degrees would be full circle back to the prime meridian. So the international date line is at 180 degrees longitude, okay? And I just gave you G. The prime meridian is at 0 degrees longitude. All right, north of the equator is called which hemisphere? Northern. It's not hard. And then I, south of the equator, is called the southern hemisphere. All right, you might need to look back for this one, although it shouldn't be too hard because when you're talking about time zones and how far apart they are in time, each time zone is an hour apart. So how many time zones are on the globe? Well, think about it. It takes how many hours to get all the way around one full rotation? 24. 24 hours in a day, one time zone for each hour. So the entire globe is divided into 24 total time zones. These are just the US ones, okay? All right, section 2, you should be able to complete. You're finding the approximate miles from the equator, just like we did here. I'll move this over again. Okay, so section 2 is just going to be like this. We don't need to go over those. Section 3, completing the chart. Just like we went over and reviewed here, you're going to fill in the times. Section 4, use those word problems to solve, whether it's a time zone and a time issue or a distance issue. You need to solve those. Cross off 5 and 6. We didn't do circles. We didn't do drawing angles and measuring them and bisecting them and all that. For section 7, you're going to complete and solve these problems, but I did want to do G real quick together. I'm going to grab a marker and sit down here because I still see some of you making common errors here. So let's go over problem G. We've got 7 1/4 minus 6 3/8. Hey, yes, I know most of you have gotten this, but let's just make sure we all get this one correct together. When I convert this to a common denominator, because I can change them both to eighths, I cannot do 2/8 minus 3/8. All right, we haven't even gotten to negative numbers yet, but first of all, this entire number is bigger than this, so we can't have a positive whole number and a negative fraction. So we have learned that we can borrow, basically 1 whole from the 6. Sorry for the messy writing. I'm trying to write sideways. That does say 8/8, I promise. All right, but these two are together. The whole point of borrowing is to put these two together so that this fraction can help out this one. So all together, combined, I now have a fraction of 10/8, which is very easy to subtract 3/8 from. So when I subtract, there's 7/8. There's nothing to simplify. And then 6 minus 6 is 0. This is all I'm left with. So there's several steps I've got to remind myself. First of all, I need to have a common denominator. Okay, so I double it to get the common denominator of eighths. I can't do anything with fourths and eighths when I'm adding and subtracting. All right, 2/8 was not big enough to subtract this. So I had to borrow a whole from the 7, making it a 6. But instead of using it as 1, I'm going to write it as a fraction. We know that a number over itself, like 8/8, because I'm using eighths, is 1. So I'm taking 8/8 together with that 2/8 to give me something like 10/8 where I can very easily subtract. All right, so that was just that review. All right, it is up to you then to go ahead and complete the sheets and filling in all the problems except for, was it 5 and 6 or 6 and 7? 5 and 6 we didn't want to do on these pages today. Otherwise, everything else should be complete. And I will see you in the next math lesson, and hope you're having a really good day. Bye, guys.